the Victorian era, you could make a lot of money if you had some luck and a really good idea. One chap who did just that up here in Northumberland was William Armstrong, who spotted the power in moving water and made himself a fortune.
William Armstrong began his career as a lawyer, but his real passion was engineering. He invented hydraulic machines that transformed industry, and he became one of the richest men in Britain.
And this, Newcastle, is where he made his money. The thing was, in 1837, when Victoria came to the throne, Britain was iron and steam engines. And we'd just recovered from the economic disaster of the Napoleonic Wars. So there was tremendous boom in imports and exports. And the docks here in Newcastle were fantastically busy. Armstrong invented the hydraulic crane, the perfect tool for getting all the goods onto the ships and off again. The principle of hydraulics is really quite simple. Just look at these two syringes. One is much bigger than the other. If I push this big plunger down a little bit, watch how much the little one moves. You see, it's moving up about 5 times as fast. So you can get 5 times the movement. But the really clever bit is to run it in reverse. If I put a little weight on here, it'll lift a much bigger weight the other side. 1 kilogram shoved on there would lift 5 kilograms on the other side. So you can use hydraulics to multiply force.
Armstrong's business grew to become the biggest on the Tyne. In 1868, he even had an entire bridge demolished, replacing it with a hydraulic swing bridge to enable ever bigger ships to get to his works. After almost 130 years and 250,000 swings, it's still in perfect working order.
William Armstrong used all the money he made from hydraulics to jump onto another bandwagon. He made guns and warships, and he wound up employing 20,000 men. He was the biggest industrialist in the country, and that brought its own rewards.
At Rothbury, in the heart of the Northumbrian countryside, William Armstrong built Cragside, one of the most luxurious houses in Britain and the first in the world to be powered by hydroelectricity.
He got his power by bringing water down these cast-iron pipes from Nellie Moss Lakes, 100 metres up the hill, and of course it arrives here with tremendous pressure. And he used all that pressure of water to drive this turbine. In here there are buckets being forced round by all that water. And once he's got that rotary motion, he's able to generate electricity using this generator. And he made 10 kilowatts of power.
Armstrong used his electricity to make his house a showcase of the latest Victorian technology. Even members of the royal family couldn't resist an invitation. Cragside became known as the Palace of the Modern Magician.
In the bedrooms, there were electric bells to summon either the maid or the valet. And when it was time for dinner, they saved muscle power and lung power by using an electric dinner gong. Electric fire alarm. He even had a telephone. Hello? Hello? Basically, it was to call for more power from the powerhouse, but of course he was one of the first people in the country to have a telephone, so he couldn't phone anybody else. But the most amazing thing about Cragside was this, the electric light.
Cragside was the first house in the world to be equipped with the light bulb, developed by Armstrong's close friend, Joseph Wilson Swan.
And this is it, or at least this is one of his very, very early ones, made by his own hands. Beautiful object, with a hair-thin carbon filament in there.
Swan had struggled for almost 20 years to make his light bulb. Like other inventors, he knew that if electricity could be used to replace dim candlelight and smelly gas, there were fortunes to be made. The problem was actually making it work.
Here is my light bulb. Everyone knew that if you took a wire filament like this and passed a current through it, it would glow, and that was the whole principle. But there was a little bit of a problem. Just watch this. Now, I'm going to pass my current through, gradually increasing it, but oxygen in the air gets to the filament, hot spots develop, and it simply burns out. They realised that what they needed was to keep the oxygen away from the filament so that it wouldn't burn. Now, they used vacuum pumps, but I'm going to cheat. This is easier. I'm using liquid nitrogen. It's boiling off furiously, blowing out all the oxygen and filling the flask with nitrogen gas. Now, that means with luck there'll be no oxygen in there for the filament to burn in. I'll try now putting some electricity through my filament, hoping for the best. There we are, and it seems to be glowing nicely. Terrific. It's really bright. It's not burning out because it's in an atmosphere of pure nitrogen. There, look at that. I'm lit up by an incandescent lamp. I've invented the light bulb.
From water power to electric light, Victorian inventors were making it big.
After a terrible epidemic of cholera swept through Bradford in 1848, a rich mill owner called Titus Salt decided his workers deserved a better deal. So he embarked on an ambitious project to build them a utopia out in the countryside, away from all the pollution and disease. Salt chose a beautiful spot in the heart of the Aire Valley, and he called it Salt Aire.
Salt owns 7 woolen mills in Bradford. So, to get all his workers under one roof at Salt Aire, he needed to build a mill of unprecedented size.
Up here on the top floor is what used to be the biggest room in the entire world. It's an incredible space, almost 200 yards long. There were hundreds and hundreds of workers in here. A massive production line. Every day, the factory produced 18 miles of cloth.
But the mill was only the beginning. Over the next 23 years, Titus Salt built a whole town. Along streets named after his family and even his wife's friends, he built 800 houses for his workers.
He built shops, schools, a community centre, and a hospital. He even provided allotments so that the residents of Salt Aire could grow their own fruit and veg. In fact, there was almost everything you needed, except a pub.
When Titus Salt died in 1876, 100,000 people came to mourn his passing, and he was buried in the church that he had built.
Titus Salt had thrown down the gauntlet to the other great industrialists of the day. He was one of a new breed of philanthropists who realised that when you employ thousands of workers, you have a real responsibility to the community.
For the mid-Victorians, business was booming. But it wasn't all good news. More business meant more traffic. And London, the world's financial capital, was grinding to a halt.
But that in itself was a business opportunity. If anyone could solve London's traffic problems, they'd make a fortune. The only trouble was there wasn't any space to build new roads. So perhaps the answer was to build a new railway underground.
In the 1880s, private investors took a huge gamble on a radical electric transport system 100 feet below London's streets.
Mike, it's very dark in here. Where are we?
You're standing at the bottom of one of the shafts that was excavated to help in the construction of London's tube railways. The idea was basically to sink a series of shafts, which were basically where the stations were going to be for most of the railways, and then they could actually dig the running tunnels between the stations.
Whose idea was it in the first place?
Really, you can look to a man called James Henry Greathead, and he'd seen things like the construction of Lambeth Bridge, where people were using cast iron pipes to help form the foundations. And along with a colleague called Barlow, they came up with the idea, well, if you could turn this technology, this pipe technology, truly on its side, it would enable you to quickly, cheaply and efficiently dig tunnels under cities like London.
If you were a Victorian banker or an insurance broker, Your whole livelihood depended on a few very special books, because in those days before electronic calculation, you needed tables like these ones, Calais 1795 log tables. This was the only way that they could assess risk. And these had to be accurate, because if they weren't, well, things could go badly wrong. It made the difference between wise investments and financial disaster.
These tables were calculated manually by men called computers, and human error was wreaking havoc. One single mistake cost the government £3 million. But an eccentric inventor called Charles Babbage proposed a radical solution.
What Babbage imagined was a mechanical computer. He'd reduced complicated calculations to simple additions, and he reckoned he could put together cogs like this that would do those additions automatically. Let me try and show you the basic principle. Suppose I want to add 7 and 5. Now I set this one up to give us 7 there, and I set the middle one up to give us 5 on your side, so that'll be there. That's 5. And now we're going to get the result out here, and I need to turn this one round so it's 0. So we've got 7, 5 and 0. Now all I have to do to get the answer is to turn this one back to 0. So I turn it round like this, 4, 3, 2, 1, 0. There we are, 1, 2. The answer 7 plus 5 is 12. And that is the heart of Babbage's difference engine. Sadly, although he eventually spent £17,000 of government money, enough for 2 warships, he never did finish it. In fact, this, 1/7 of the machine, was all he managed to complete. The government, of course, were furious. One of them said, all we got for our £17,000 was Mr. Babbage's grumblings. We should at least have got a pretty toy for our money. And so they pulled the plug. They took away his financial support, and most of his parts were melted down for scrap. Babbage was certainly a genius. He dreamt up all sorts of things, including an even more advanced computer and flashing lighthouses. But none of these things made him any money, and he was a very miserable man.
Not all inventors thought big. It was often a better bet to come up with something small that people really wanted. And as Victorian literacy continued to increase, more and more people needed to write.
For most people, that meant a quill pen like this. Now, quill pens are quite fun to use. You cut the thing diagonally and then you write with it like this, but the trouble is they're very soft, and so it wears down, and sooner or later you need a new one. The only option was a handmade metal nib, probably a gold one like this, and these were far too expensive for most people. Joseph Gillett came up with the answer. He produced steel nibs. He adapted a button pressing machine and turned these out at a shilling each, as cheap as the quills and as long-lasting as the gold. It was a runaway success. In fact, he made so much money, he didn't know what to do with it, and he even started burying it in his cellar. But then he started collecting antiques, and he became an important patron of the arts. He actually discovered an unknown painter called Joseph Mallard William Turner. He went to visit him in his dingy house and offered to buy a painting. Turner, who was a grumpy artist, said no. And so Gillett said, all right then, what'll you take for the lot? And Turner was so amazed that he named an enormous sum of money, and Gillett calmly got out his wallet and paid him in cash. Well, Gillett made loads of money, but he could hardly have foreseen that the material he'd used for his pen nibs, steel, was about to transform the world. With buildings made of brick and stone, you could only build to a certain height because the building got too heavy. But once you had a steel skeleton and walls simply hung from it, you could build quickly and as high as you liked. The first steel frame building in the world was built in Chicago in 1885, and in 1896 they built one in England at West Hartlepool. It was a completely new way of thinking about building, and it opened the door, literally, to some rather confusing inventions. The revolving door was invented by Theophilus Van Kannel in 1888, and the idea was first to get all these people in and out of the building very smoothly. But actually there was a more fundamental reason. Because of all the hot air rising in the building, there were terrific drafts through ordinary doors and you couldn't get them open or shut. And then there was the escalator, which started life as a fairground ride, invented by Jesse Reno in 1891 and turned into a practical system by a chap called Charles D. Seeberger in 1899. But a big problem with these high buildings was that people weren't prepared to walk up more than about 4 flights of stairs. So the most important innovation of all was the safety elevator, invented in 1852 by Elisha Graves Otis.
Most people thought that the idea of travelling in a lift was too dangerous even to contemplate.
Otis was convinced he had a mechanism that would prevent the lift from plummeting to the ground even if the cable snapped. But nobody would believe him, so he had to become a showman, and he built a gigantic wooden model at the New York Exposition of 1853. Let me show you how it worked. When I pull down the rope, which is going to lift the lift, you see the rope's tightening up, and now this becomes horizontal, this spring compresses, and this spigot here disappears inside the lift car. But suppose the rope breaks like that, then what happens is that that spring pushes the lever down, pushes the spigot out, and so it's going to engage with these teeth. And that means that the lift cannot fall. That was the secret of Otis's mechanism. Sadly, Otis died at the age of 50 and never lived to see his wonderful invention transform the skylines of the world. But his elevators certainly made it big.
But skyscrapers weren't the only invention to come from abroad.
In the summer of 1868, velocipedamania came to this country from Paris. And about 50 firms rushed into production of funny machines like this one, which came to be called the Bone Shaker, although actually it's rather comfortable. I'm sitting on a bit of sprung steel. It's very heavy, and really, it was more a toy for rich young chaps, not a serious means of transport. Nevertheless, this was how the bicycle came to Britain.
The cyclist didn't have the road to himself. He often got held up by a self-propelled vehicle.
And this is it, the horseless carriage. Michael, this is a steam carriage, yes?
That's right, yes.
Aren't you a bit bothered having a great boiler with high-pressure steam underneath?
It's not as big as all that, and there isn't that much steam down there, and I trust the engineers.
Victorian technology was ever advancing, and a brand new engine was about to change everything.
The steam carriage was coming to the end of the road because it was about to be overtaken by this. This is the petrol-driven car. Fantastic new high technology, isn't it wonderful? Unfortunately, the development of these things was held up by the Red Flag Act, originally 1865, which said that any horseless carriage had to be preceded by a man walking, waving a red flag to warn the other road users. And the maximum speed limit was 2 miles an hour in town and 4 miles an hour in the countryside. Michael, what happened to the red flag?
Well, 1896, the Act was repealed. It was no longer necessary for you to have a man walking in front of your heavy or light locomotive, and the speed limit went from the 4 miles an hour up to 12 miles an hour in the town. 12 miles an hour in the town and 14 miles an hour in the countryside.
Wow. And was there any sort of celebration?
Yes, there was. The Motor Car Club ran an event, a run from London to Brighton, just to prove to the public that motor cars were reliable. There was a man called Harry Lawson, either entrepreneur or charlatan, depending on your view, who'd come out of the bicycle industry and had bought up a whole lot of patents in the car industry, so that quite a lot of the cars taking part in this first run actually came from his manufacturers.
How many?
22 out of 33 were his.
22 out of 33. So presumably he won then?
No, he didn't. No, he got it all wrong.
Excellent.
Because 2 cars came over from America, the Duryea brothers, and one of those got to Brighton first, even though it wasn't a race. And Harry Lawson, of course, complained and said they'd cheated because they hadn't stopped for a luxurious lunch in Reigate, which is what competitors were supposed to do.
Despite losing the race, Harry Lawson claimed victory anyway. He used the London to Brighton rally as a springboard to become one of the biggest early car makers, and he built himself an empire.
The Victorian age was a tremendous time of opportunity for entrepreneurs. They did amazing things for us, everything from hydraulics to the motor car, and it was this that drove us into the 20th century.